Okay, I thought we'd throw together a little recap of last week. Since we're doing this video experimentation, here we have a video of the summary of everything we did last week. So on Tuesday, you were introduced to vertex form of a quadratic. Vertex form is y equals a, parentheses, x minus h squared plus k. And if you're given the quadratic in standard form, how you figure out a, h, and k, a is a, h is negative b over 2a, and then to find k, you plug h into the function to get k. Bump. Wednesday was word problems, using, again, the stuff we had done Tuesday to get the vertex, because often they want to know when the ball hit the max height. So the h there is negative b over 2a, k. You plug in h into the function to get k. The other thing you had to do with word problems is find solutions or find when the ball hit the ground, and those are your x-intercepts. If it's when the ball hits the ground, it's your second x-intercept right there. And with the geometric word problems, any positive x-intercept is your solution. Remember, you can't have negative distance. Thursday, you did inverses and horizontal parabolas. Inverses are simply defined as a reflection over y equals x. If you just have a point, you're going to swap x and y. So if you have 2, negative 3, the inverse is negative 3, 2. If you're trying to define the function, the inverse, then you'll swap x and y and then solve for y. Horizontal parabolas are just like vertical parabolas, but instead of being y equals, you have x equals, and that means every x and y have changed places. So x and y here were here, so since it was y and x there, now it's x and y here. H and k also swap places. So what that means is, if you're given a horizontal parabola in standard form, a is a, but when you do negative b over 2a, that gives you k, and then to find h, you plug k into the function. Friday, function composition. This is what you guys casually call fog x. What that means is you're substituting functions into other functions. So this is an example here. If you let f of x equal 2x and g of x equal negative x squared plus x, for a number example, evaluating it for a number, for example, if you had to find f of g of negative 4, what that means is you first need to know what g of negative 4 is. So substitute negative 4 into g. G is right here, so everywhere there's an x, I'm putting negative 4 in g. Negative 4 squared is 16, negative 16 minus 4 is negative 20. But that's only g of negative 4, and they asked for f of g of negative 4. Since I know g of negative 4 is negative 20, and now I'm going to do f of negative 20. F is 2x, so I'm going to put negative 20 everywhere there's an x and f. That gives me a value of negative 40. So for our final, answer, f of g of negative 4 is negative 40. Now if you're doing it for a function where there's no value for x, so for example, this is what I call an x example, we're going to do g of f of x, which means we need to put f of x into g. Well, f of x is already defined as 2x. So what that means, if we want g of f of x, we want g of 2x. So everywhere there's an x in g, we're going to put 2x. And just make sure that after that you just need to simplify. 2 squared is 4, x squared is x squared, bring down the negative, and you're done. So g of x is equal to negative 4x squared plus 2x. And that is sort of a window view of last week and almost absolutely everything you need to know for the test. Hope that helps.